Let's look at physical and chemical change today. So physical change is a change in the form of matter, but not its chemical identity. Okay, so when the substance changes, but it's still the same thing. So for example, any type of phase change, I like to say phase changes are always physical changes. So melting, boiling, evaporating, any of those is a physical change because of the fact that it is still the same substance if you just change the temperature to change it back to its original phase. Now, another example of a phase change could be something like having a piece of paper and ripping it up into smaller pieces. It is still paper. It's just a smaller form, or taking a rock and crushing it. That's another example of a physical change, just changing the shape or the size, but not the actual object. Okay? Now, a chemical change is the opposite. It is when we are actually changing the chemical composition, and oftentimes this is some sort of chemical reaction. So, for example, when it oxidizes, rust on your car is an example of when something oxidizes. You cannot get rid of rust. You just have to sand it down to get to a lower level there. Something burning, cooking something, if you were to bake a cake, therefore you could not get back that original batter. Anything that is non-reversible, okay, or irreversible. So that's an example of a chemical change. Now, the noun version of this is physical and chemical property. So a physical property basically is the property when something occurs without changing its chemical identity. So it is, again, the same object. Okay, so if you take something's boiling point or look at its color, that's an example of a physical property because you're not affecting any change. It is still the same object. Okay, or just saying if it's a solid, a liquid, or a gas. Now, if something is occurring, such as rusting, as I said to you, or photosynthesis is occurring, you are baking it, or you're washing some layer of it off, some sort of explosion or something like that, that's a chemical property. And again, that is involving a chemical change. You cannot go back to that original state. So some sort of ability to react with oxygen or fluorine. Reacting being that big word there. When you see reacting, you know that you are getting some sort of new product after. Okay? Now we're going to go ahead and look at the hierarchy of matter, and let's first review what matter is. Matter is anything that has mass and takes up space. So everything in our universe is some form of matter. Now, matter can be broken up into a whole bunch of subcategories, and that's what we're going to look at today. So matter can be broken up into pure substances or mixtures, and you're going to have to know how to break these apart, okay? So pure substance can be then further categorized into compounds and elements. So I'm going to first focus on elements. Elements are anything that you can find on the periodic table, okay, which in this class is something we're going to look at a lot. So it has to be found on the periodic table. So for example, hydrogen, oxygen, carbon, iron, it could be, mercury. There's so many options. So anything on a periodic table is an element. Now, for it to be a compound, it has to be two elements together or multiple. It could be more than two. So I'm going to say 2 plus. So for example, and a lot of times you'll be given this formula, water is H2O. So there's 2 hydrogens and 1 oxygen. So that is a compound. Salt, which is NaCl. Okay, so 1 Na, which is sodium, 1 Cl, which is chlorine. So if it was just an Na, it'd be an element, but when it joins with Cl, it's considered a compound. Okay, so multiple elements together. Now let's go ahead and look at a mixture. A mixture is something that can be physically separated, where pure substances cannot. And we have 2 mixtures, homogeneous and heterogeneous. So homogeneous is the same throughout. Okay, and I actually have some examples and some definitions right on the next slide here, so hang tight with that. And heterogeneous is different throughout. Okay, so you're able to see the different components of a heterogeneous, where homogeneous is going to look all the same. So here is just some formal definitions of this. So again, we said an element is a substance that cannot be decomposed or broken down into anything simpler. And oftentimes, or actually all the time, we're going to find an element on the periodic table. So that's a nice check for you. Now, when you have multiple elements, two or more, coming together, we have a compound. So I said H2O, water, or CO2, carbon dioxide are good examples because there's multiple elements in there. Then the other side of that table is mixture. And again, we referred to homogeneous mixture being one that is uniformly distributed, meaning it is all the same throughout. You cannot see the different components. Where heterogeneous is not evenly distributed, you can see the different components of it. Okay, so I'm going to give you some examples here. So homogeneous could be maybe a glass of juice, so maybe just an apple juice or something like that. When you look at it, you see only the components of the apple juice. You do not see the sugar in there. You do not see the fermented apples. You don't see all the other preservatives, but you know it's there, okay? But when you look at the apple juice, it's only the apple juice in there. Now, heterogeneous, for example, could be cereal and milk. So maybe you're pouring yourself some cereal and milk for breakfast. You can see the cereal, you can see the milk. Those are two different mixtures, but you can see the difference, okay? So theoretically, you could separate them. So that's an example of heterogeneous, and we also have homogeneous, okay? Okay, so now we're going to go ahead and classify as an element, a compound, a homogeneous mixture, or a heterogeneous mixture, okay? So pasta salad, when you think of pasta salad, you're seeing pasta, you're seeing vegetables, you're seeing Italian dressing. There's many components of pasta salad. Now, those are not specific elements, those are not compounds, but they are some sort of mixture of items. Now, when you look at pasta salad, can you see the different components? You can, therefore it is a heterogeneous mixture. Okay? Now salt, I'm telling you what that is. That is one Na and one Cl coming together here in multiples of those. So when you see two elements together, we know that is a compound. When we have just one single element, and you could verify that on the periodic table, we know that that is just an element. Now brass, you're not expected to know what makes up brass, but it's actually a mixture of copper atoms and zinc atoms. Now because they are not joined together, so for example, let me show you what joined together would look like. This is not a real component, I just want to show you. This is joined together, okay? That is not what we're looking at. We're looking at two separate pieces of copper and pieces of zinc that then end up melt together. So because they're hanging out together like that, we're going to say that they are some sort of mixture. Now we need to ask ourselves, is it homogeneous or heterogeneous? So if you had a piece of brass, okay, you would say, can I see the copper? Can I see the zinc? You cannot. So therefore that is going to be homogeneous. Okay, homogeneous mixture. All right, pepperoni pizza, so that is definitely homogeneous, or excuse me, that is heterogeneous. You can see the cheese, you can see the pepperoni, okay? You can see the different components. It is heterogeneous. All right, now caffeine, you can see this compound. It is all together. It is not a plus sign. It is all together. So C, H's, N's, and O's, okay? When they're like that and together, we're going to say that that is a compound. And then we have chocolate milk. So if you're looking at a glass of chocolate milk, similar to that juice example, we can see just one component there. We cannot see the milk, the chocolate, the fats, everything. So we're going to say that that is homogeneous. All right, now we're going to go ahead and look at molecule diagrams here. So let's go ahead and see what we have. We're going to label these as either a mixture, a compound, or an element. So one of these goes with each term. So remember, an element is just something by itself. I like to get that one out of the way to kind of narrow it down. So the one by itself, we're going to say for sure is A. So A is an element, okay? So knock that off. Now we have B and C. Let's look at the difference. B is the same thing many times over, something gray in the middle and red on either side. So because it is the same thing over and over again, that is going to be some sort of compound. And then if you look at C, process of elimination tells you it's a mixture, but let's see why. You have single things here, you have double things here, they're all kind of just floating around together, so therefore that is going to be a mixture. If it's all the same throughout, it'd be homogeneous. If it's different, it would be hetero, but we don't really have enough information to be able to tell that. Okay? All right, that finishes us off for today for that concept.